Hi friends, this is Taimur. Welcome to my channel, The Cloud Security Guy. If you're new here, I talk on a weekly basis about things like cloud security, artificial intelligence, and general cybersecurity career advice. So today we're going to be continuing my CCP exam crash course. This is a completely free overview of the CCSP exam domains. If you're not aware, the Certified Cloud Security Professional CCSP, it's one of the best certifications in the world with regards to cloud security. And what I'm going to be doing is domain by domain. I'm covering all the domains and basically helping you prepare for the examination. And like I always say, this is like a crash course. So if you have not done anything, if you have not studied the books, not done the practice questions, this course is not going to magically make you pass the examination. I've made this for revision, for clearing up your concepts. Like I said, it's always good to have a revision before the examination, but please do not just depend on this course for the CCSP, okay? Before we start, please do like this video, subscribe to this channel if you haven't already. That will really help the channel to grow and reach the maximum number of subscribers. Okay, so let's start, guys. Like I said before, there are 6 security domains within the CCSP common body of knowledge. So you can think of them as the 6 like subject areas that you must master in order to pass the examination, right? And today we're going to be covering domain 5, which is cloud security operations. That comes to around 16%. Okay, this is the topic. So cloud security operations, it covers a very broad area of security operations in the cloud. Everything from managing your data center security, collecting and preserving evidence, cloud forensics, security operations center. Like I said, I think previously it was 17%. Now it comes to around 16% of the examination, and we're going to be covering a lot of topics. Okay, so let's get started. First one is implementing building a physical and logical infrastructure for the cloud. So, you want to securely operate a cloud environment. First step would be to implement and build your physical and logical infrastructure, right? With security in mind. You need to have that foundation. So this in this section, we're going to look at the careful planning, implementation of physical components like servers, networks, equipment, storage devices, and all the apart from the hardware, the logical infrastructure that have to be there. Okay, so hardware specific security. So when you talk about like you're building a data center for the cloud, right? There are some hardware considerations you need to keep into mind, right? So just like an on-prem, a cloud data center's infrastructure, it begins with its physical hardware. You have to think about servers, networking, storage, and devices, components. Same thing that you would find on-prem, right? But you need to think about other things also, right? And especially when it comes to security, because you can imagine like how many servers there would be in a cloud environment, right? From AWS and Azure. Can you imagine how many things there will be there? So you need to think about security at the hardware level. First thing would be the basic input output system or BIOS. If you've ever worked in Windows and all that, right, you might be familiar with this. It's like a firmware that initializes and tests your computer hardware before booting the operating system. It's the first code that runs on a machine when it is first powered on, right? All physical computing devices, whether it's on-prem or cloud, they have BIOS settings that configure the hardware and manage the data flow between the OS and the other components. And because it's the first code that a computer sees, a BIOS is incredibly powerful and it's very important to protect, because if you compromise the BIOS, it can have a major impact on your system security, and it can impact the functioning and security of the hypervisor, which we talked about earlier. If the hypervisor is compromised, basically everything is compromised. So it's very important that the cloud provider, it tightly restricts access to the BIOS settings and limits the ability to be accessed or modified by anyone, right? Like we talked about least privilege. Even the least privilege, that has to be closely monitored because of how critical the BIOS is. Next one is the trusted platform module, or the TPM, and virtualization. So basically, the TPM is a microprocessor. It's like a microcontroller. That's a computer chip, right? It's designed to provide hardware-based security functions. So it's like a secure crypto processor. It's like a dedicated chip that carries out cryptographic operations. It secure stores credentials, passwords, certificates, encryption keys, and it can be used to ensure that a platform or system is what it's claiming to be, right? It's basically authenticating. And usually these chips are physically secured, so they're tamper proof, tamper resistant, so that nobody can like no software can interfere with the function, right? Nobody can interfere with the how the function is working. And because it's hardware based and physically secured, so it can help to protect against somebody trying to compromise the operating system, like an admin abuse or other software-based vulnerabilities. It was standardized by the ISO, this concept of a TPM. And you will see this in a very, very critical systems. They will have this concept, right? Like cryptographic, like hardware security modules, HSMs, all of those things, they have that concept. And it provides you a lot of functions like platform integrity. So it can make sure that the platform, like whatever computer device, it's like booting up into a known secure state and it's behaving as intended. The TPM will make sure. Drive encryption, full disk encryption tools like BitLocker, they have this functionality to give, and you have that concept of a TPM over there. Okay, so all those things are present there. And just remember, the main thing is that if an attacker, it compromises your operating system, it's not able to gain control because the compromised operating system, it will not be able to pass the checks of the TPM. Okay, and one thing, passwords also. So passwords that are stored or authenticated using only software, they can be compromised. But by storing passwords in a TPM, they are protected from such attacks and they allow very secure authentication. So that's the reason CSPs use TPMs to protect the critical infrastructure, because the demand for security is so high. You have to understand, right, why the TPM concept is so necessary in a cloud environment. So next one is storage controllers. Storage controllers, or a disk array, is basically a device that manages and stores storage devices. It's like, what it does is it integrates multiple virtual storage units into a single logical pool, and that is used to dynamically read and write data. It has many security features like encryption. So it encrypts data at the controller level before being sent to the disk, right? So it makes sure that nobody can compromise it. A lot of vendors, they have their storage controllers with their own security features. But as a CCSP, you will be required to probably evaluate vendor specific security features, right? And even for virtualized environments, the storage controllers, they have like segregated on their own network so that you can apply very, very sensitive controls over there to make sure nobody can compromise. Yeah. So this is the whole concept of how storage controls are working. Next one is network controller. So network controller, can you imagine in a like a big data center for the cloud, right? Like for Azure and AWS, how many networking devices there must be? Can you imagine? So network controller is a centralized point of control. It's used to configure, manage, and monitor physical and virtual network infrastructure. You can automate all the management, and honestly, you can, because doing it manually is simply not possible, right? So it's an integral part of the whole thing we talked about earlier, software-defined networking, and it's a very, I would say, it's a key requirement for having a cloud environment, because it's simply not possible to manage all those things manually. So we've talked about virtualization many, many times, right? You can understand. There's a reason for that, because virtualization is pretty much the backbone of cloud infrastructure. And it has management tools, right? They interface with virtualized components as well as the underlying hardware to make sure that the management is happening properly of the virtualized environment. Because there's such a heavy reliance on virtualization. That's why you see so many questions and so many topics being covered. As a cloud security professional, you need to make sure that these management tools, they are securely installed and configured, because they're managing the hypervisor and the management plane, right? They have to be protected, because if somebody compromises this, he can pretty much compromise everything, right? The entire infrastructure. So there are many types of virtualization technologies and so many virtualization vendors. Each of these vendors probably have their own tools and guidelines. So as CCSPs, you will be required to have at least have a good knowledge of how to secure a virtualized environment. Make sure you're completely familiar with this topic when you're attempting the examination. And aside from properly installing and configuring them, you need to take a look at the other things also. After it's live, patching them, making sure that the least privilege is there, nobody has admin access. Like you don't want to give like an intern and admin access to your virtualization hypervisor, right? All those things, you should be logging them, monitoring them, who is accessing it, how it's happening. That's why the virtualization, this particular management tools, they are so very, very critical. Apart from the management tools, we have hardware security requirements also, right? So configuring virtual hardware, it requires, you need to be aware of the underlying physical hardware also. Why? Well, let's take an example. Suppose you spun up a virtual machine, and the physical server, it only has a storage of 100 TB, but you configure the virtual server to have a 200 TB. Obviously, this will cause a problem, right? That's why it's so much needed to sync the virtual and the physical worlds, right? And vendors usually, they document all the configuration for the virtualization products, and you should be aware of them. You should know how to store them. So, and apart from that, for the hardware level, you would have the networking security also, right? Physical networking devices, and they have to support like they have to be secure also, all the hardwares, all the virtual like the network IDS IPS logging, all those things. You have to be using tools which are properly configured for such an environment. And apart from that, the storage security. Again, you will have many vendor guidelines how to configure them. Nobody should be able to access. MFA should be there. Logging should be there. Hardening should be there. All of those things you need to understand. So the same things we talked about earlier when it came to hardware security, that will be applied to the virtual hardware also, as well as the logical hardware. Okay. Okay, let's. So after you securely implemented and built your physical and logical cloud environment, your attention must turn to the securely operating that environment, right? So operating, what does that mean? It means implementing access control, securing the physical and logical access, building and deploying hardening OS baselines, ensuring that everything is available. You will have many guidelines, but you need to be aware of all the concepts that are come now that you've implemented a cloud environment and it's running. What do you have to do? So let's take a look at the access control, right? So configuring access control for local and remote access. So when thinking about access control, a lot of attention usually you give to controlling access to customer data environments and their data, right? And that's important, right? And most of this course is focused on that. But you have to understand, you have to focus on access control for the underlying cloud infrastructure also, right? Because if somebody is able to compromise that, he can pretty much access every single customer's data. So you have to think about things like limiting physical and logical access, physically securing buildings. So there are many mechanisms that are there. So we look at three of them. One is the keyboard, video, mouse, console access, and RDP. If you have ever worked in a data center, I mean, I'm sure you will be familiar with it. All of these methods, they require things like MFA and logging and monitoring, right? But let's look at each of them. All of them would have those controls, but let's look at each of them. So secure keyboard, video, mouse, KVM. Like I said, if you've worked in a data center, you'll be aware of this, right? It's like an input-output device that allows a user to access and control multiple computers from a single keyboard, video display, and mouse. They provide physical access to devices, and they can be like located in multiple separate physical locations in cloud environments. So a single administrator can access multiple devices of different security levels, right? And usually these are designed to ensure data isolation between the systems that are connected to it. You'll have an isolated data channel, so you can't copy data out, right? And usually you might have one KVM control server, so it can't access the other data server, and restricted IO, so you can't have put in your USB devices and other storage devices, right? Push button control, so you can put like it might have a physical button that can be pressed in order to switch between the connected devices. So it makes sure that like remotely nobody can compromise it, because you need to have like a physical access there. And sometimes the firmware is locked also. It's like impossible to reprogram, and if you try to access it, it shuts down. And usually it has tamper proof components and physical security, because they are usually physically secured. That makes it like very difficult to open if you don't have access. So like I said, if you've ever been to your data center, you'll see these sort of things which are generally present because of the high level of access they have. Apart from that, we have console based access, right? Every hypervisor that is there, it offers a console based way to configure and manage VMs, right? And if somebody compromises the console access, it can allow an attacker to get like very powerful control on the hypervisor and all that. That's why it's so very important to control this, right? A lot of, like I said, the vendors usually give you guidelines on how to harden them. And lastly, remote data protocol, RDP. If you've worked in a desktop environment, you'll be familiar with this, right? It was a RDP is a protocol developed by Microsoft, which allows you to connect to a remote computer over a network, right? And you can interact with the remote computer via like the graphical interface. And usually you need some sort of client software which must be run. So now it's pretty much available for all of everything, like even Mac OS, Linux, Unix. But like I said, RDP has to be properly secured and monitored, especially when it's accessing critical systems, right? And usually RDP is like a prime target for attackers, because if they compromise it, they can usually access it. That's why it's so important to actively scan and patch all the systems which are being used for RDP. It has to be configured with role-based access. You need to prepare controls, and you absolutely do not want to allow RDP over the internet. A lot of people make this mistake. Please do not make this mistake. Okay, so we've covered that. Now let's take another thing, which is secure network configuration. So when you're talking about this secure network configuration in the cloud, it usually involves the use and configuration of several technologies, like VLANs, TLS, DHCP, DNS, and VPN. And you must understand as a CCSP the key concepts and like how they work and what are the like how you apply them. Firstly, like virtual local area networks, VLANs. It's like if you've ever done networking, you'll be familiar with this, right? It's like a set of servers and other devices within a LAN that are logically segmented to communicate with each other as if they are physically isolated. You have something like a LAN and you have a VLAN. So network isolation and segregation, they're very, very important, right? Especially when it comes to securing cloud environment. So when physical isolation you cannot do, and typically that is what it is in the cloud, because you have too many, each customer has their own VLAN, right? So cloud providers and customers, they rely on VLANs to enable virtual network segregation. So, like I said, it acts like a physical LAN, but it allows devices to be grouped together regardless of like which switch they are on. And you can virtually group services, group devices that are physically separate, and you can segregate them. So it's a great way to abstract. And common use cases, like you want to separate your production and development environments. You want to separate your tenant environments, separate different zones or planes. You want to segment off your storage controllers we talked about from your list of your environments. So all those things, it comes into play. The second one is TLS. I mean, I'm sure you must be familiar with this TLS. Basically, it replaced the SSL old standard. It's pretty much the de facto standard for encrypting network traffic. It's made up of two layers. It's like the record protocol, which provides the actual service secure communications for data in transit, right? It encrypts the connection with symmetric key encryption, and it uses it to encapsulate other, like what data is going. And the TLS handshake protocol is there, right, which allows two parties like a client and server to authenticate and negotiate with each other. And I think as of this writing, TLS 1.3 is the most current specification. Next one is DHCP. The DHCP is, it's like a network technology. Simply put, it assigns and manages IP addresses, subnet masks, and other network parameters. All of this you need to reach a device on a network. Without this technology, you can imagine administrators must manually configure network settings on every device. So you can imagine just how much of a nightmare it would be, right? So especially in a large cloud environment. So people sometimes don't like DHCP, but it's a cloud network's best friend, and it can help you securely automate and configure your networks. Next one is DNSSEC. So what do you call? DNS is basically the domain name system, right? It's one of the parent technologies of the internet. It's like basically the phone book. It is what allows you when you enter www dot I don't know gmail.com, instead of you don't have to put an IP address, right? It's like a decentralized naming system that translates domain names into their IP addresses and back again. So protecting DNS, you can imagine, right, how important it is, because if somebody corrupts your DNS servers, and they can do some things like DNS hijacking, do man-in-the-middle attacks. So all of those things are very secure. DNS sec is a set of security extensions to standard DNS. Basically, it's used to support the integrity of DNS data. It gives you like authentication and encryption, right? And the primary attacks against DNS is, usually they target availability. If you ever seen a DDoS attack targeting your DNS, so one thing very important, like DNSSEC is usually for integrity, but it does nothing to protect the availability of DNS. So it's like I said, denial of service attacks. You need to put in DDoS mitigation techniques to prevent such attacks, right? So like the problem with DNS is it wasn't built with security in mind. So that why it has so many flaws in it. But that's the whole thing that DNSSEC was come in and put in place. Lastly is VPN, virtual private network. So VPN, I mean, I'm sure you know what it is, but it's basically a private network that allows you to be securely extended over public network like the internet. It creates like a point-to-point connection between the private network and the device. So VPNs is commonly used like you want companies to telework, work from home or outside the office. It's also recommended when connecting to the internet from untrusted hotspots like Wi-Fi, because it creates a secure encrypted tunnel, right? And the users are able to access things as if they are physically sitting on the network. So that's why it's so important. Like VPN subject the remote device to all the same security policies and monitoring as if they were on-prem, right? So that's why it's such an important requirement if you want to secure your network. Okay, what else is there? Operating system hardening and baselines. This is pretty easy. I mean, if you've ever worked in security, hardening the operating system, you apply baselines, right? And when you want to secure a physical computing device or a logical one, first thing you want to focus always is on the operating system, right? So you have benchmarks like CIS, you apply them. It's like the best practices, which protocols should be configured, what permissions should be given. You turn off and disable any unnecessary services, unused ports, access ports, USB devices. Like you will have things for Windows baselines, Windows web servers, Linux web servers, VMware. It's a pretty standard practice, honestly speaking. I mean, if you've ever worked in security. Okay, what else is there? Standalone host. So within a computing environment, standalone host is a physical machine that operates independently from other machines. And usually they're used in traditional data centers when you want to isolate one system for another, for whatever reason. In cloud, usually the cloud service providers, they make these things available to customers who are migrating and them doing some sort of cloud migration, or sometimes it can be for regulatory requirement also. Like some customers, they have things like requirement that they cannot share the data with other multi-tenants, right? So you will have something like a dedicated host for that. In AWS, usually you can look it up, it's called a dedicated host. Okay, or sometimes it's also for licensing, because the licensing requires a dedicated host. You cannot simply port over your licensing. So in these sort of things, vendors provide this concept of a dedicated standalone host, which is completely dedicated to you. It's standalone and it's not shared with any other things. Okay. Oh, sorry. Yeah. Where were we? Yeah. Okay. So clustered hosts. So what is clustered hosts? A host cluster or a clustered host, it's a group of hosts that are physically or logically connected in such a way that they work together and function as a single host. As far as everybody is concerned, they're like a single machine. So the resources are pooled together and shared among the cluster. And every host within the cluster performs the same task. And that task is controlled and managed through software. So, clustered hosts help protect against hardware and software failures of a single machine. You can use it for load balancing, parallel processing, uh, resource sharing. So you can imagine a lot of things which are happening in the cloud. They're using clustered host only, right? You are dynamically allocating resources among the tenants. And I think we've discussed this earlier also. But and while every cloud provider is different, but more times, like 99% of the time, you're getting some sort of clustered host when you're moving to the cloud. So for the CCSP examination, you should know the difference between standalone and clustered hosts and when to use each. Okay, so now we've moved on to the next section, which is managing physical and logical infrastructure for the cloud. So we've talked over operating it. Now we're going on to the management part. Basically, to securely manage a cloud's environment infrastructure, you must configure things like, capacity monitoring, network security, a host of other things. Same things we talked about earlier, but now we're moving on to the critical areas which are related to managing physical and logical infrastructure for a cloud environment, how you're accessing it, how you're like patching it, how you're monitoring it. All those things will come into account now. So given the nature of cloud computing, you will need remote access, right? Because nobody's going to go to the data center every time, right? But and remote access to the cloud's physical environment, however, it should be restricted to very few privileged cloud service provider employees, right? And as a CCSP, you have to ensure that all the mechanisms that are there for remote access, they are fully secured and controlled. Okay, so all of these things are here, and we've talked about this earlier, like things like secure terminal access. You have things like RDP, SSH, which provides you a secure tunnel, VPN. I think we've already discussed this. I'm not going to spend too much time. We've already discussed this earlier. Okay. Okay, we talked about OS baselines, and now we're going to talk about, we discussed this earlier, we apply them, right? But you have to monitor them also. As literally in any environment, after you've put in an OS baseline, you have to monitor it. You know why? Because things will get installed, things will get removed, things will get patched. And what happens is your baseline will drift out of compliance. So through continuous monitoring, you have to make sure that the system remains in compliance. And usually what they do is you use configuration management tools. They have like automated baselines which are already there, and they scan against the baseline. They will say this is your like a baseline which was not a, like your baseline is off by 1%, 10%, 70%. Sometimes maybe you haven't applied your baseline. Sometimes an administrator made an authorized change, or maybe some malicious outsider gained access and you opened it. So that's why it's so important to have some sort of a baseline monitoring process in place that tells you if the baseline is deviating. Okay, patch management. I'm sure you're aware of patch management, right? I think everybody hates patch management in an IT environment, but basically, it's like it includes all the processes for finding, testing, and applying software patches, right? You identify the patches which are there, you acquire them. Either they come, you download from the internet, or the vendor provides you. You test your patches, of course. Yeah, I don't think anybody just goes ahead and applies patches to production, right? And then you deploy them, you validate to make sure everything is happening, and then again, of course, the cycle repeats, right? Patching is not a one-off activity, and you need to make sure that these things are happening uh, after you've deployed it. You need to make sure that no system is breaking. That's why testing is important. And one thing to remember in the cloud, that your patch management responsibilities, they really depend on what type of cloud model you're using, whether it's IaaS, platform as a service, or software as a service, right? We've talked about this before, but sometimes, like a lot of customers, they get confused. They think that 100% everything is done by the cloud provider, right? But that's not true. So if you're spinning up a server in an infrastructure as service, the cloud provider is only responsible for the physical security, right? Patching, baselining, everything is your responsibility. If you go on to platform as a service, the underlying infrastructure, yeah, that will move on to the cloud provider. But on top of that, the application patching, everything is you. And if you move to software as a service, yeah, almost everything will be done by the cloud provider itself. But it's very important to know all these things so that you're not like caught unaware, and you don't know which. This question might come up: get what type of patching is done for which model. Okay, so performance monitoring. Now, performance monitoring, that's a critical task which every cloud provider has to perform to make sure, because like we talked about earlier, right? SLAs, service level agreements. When you're going with a cloud provider, you want to make sure that your system doesn't go down, right? How do they make sure that the systems are running reliably? They have something called performance monitoring. They want to maintain like an uptime, right? They are monitoring the network, compute, disk, memory, and they have performance metrics defined, like 99.999% availability has to be there, right? They have things like net packets dropped, CPU authorization, disk, memory, excessive usage. All of those things are there in the cloud environment. And you can imagine with the clouds, how many customers they're supporting. They have to make sure that all of them are properly responding and being monitored in a proper way. Same thing with after we go to the virtual one, we can talk about the hardware one. It's like a lot of people, when they talk about the cloud, they just jump straight to the virtual infrastructure, because it's all about virtualization, right? While that may be true, it's important not to forget that underneath all of that virtualized infrastructure, there is actual physical hardware that must also be monitored. Same things, network, compute, disk, and memory. You have to monitor on the physical logic also, physical layer also. And honestly, a lot of times it's the same tools which are being used and the same things. But and you have like alerts defined. The cloud provider, they have their own teams who are monitoring things. But and apart from those metrics, you have additional things also, right? Like the fan speed, device temperature, humidity. All those things are being monitored, because any one of those things can be enough to completely destroy a server and all of the data that is there of the customers. Okay, backups. So we talked about backups earlier, I believe. So whether it's a traditional data center or a cloud environment, you must back up and restore. And that is some of the most critical security functions. You want to make sure that your critical data is backed up, easily restored when you need, right? And this forms the information security principle for availability. So you want to configure your physical host as well as any guest operating systems, that they're available after an incident or a disaster, right? You have many ways of doing it. You have snapshots, agent based, agentless. So snapshots are not like a true backup. It's like basically it's like a copy of a virtual machine or a virtual disk, and any configuration that is there. So you simply take a snapshot of a VM and you save it to a disk or a simple file. Usually people do it before deploying software patches or other potentially unsafe operations in a virtual machine if something fails. So you can simply use the snapshot to roll back to a specific point in time. And snapshots, like I said, they are not backups, because they're not complete on their way, and they rely on the virtual machine's parent disk and file system. Because if the parent disk is deleted or corrupted, a snapshot will not be able to help you, right? And usually they're saved on the same storage infrastructure as the VM itself. And while backups, usually you try to keep them separate. Apart from that, you have agent-based backups. Agent-based backups, like a lot of people used to like them. Basically, you install a component or an agent on every system and environment, and that handles the backup duties for you and sends over the desired backup storage. It takes a backup and sends it over to storage. And what do you call? After that comes agentless. I think agentless, you can imagine, right? Agentless, it's the same thing, but just this time there is no agent there, which you have to install and worry about. Okay, network security controls. So securely managing and the logical and physical infrastructure for a cloud, you need to have security controls at multiple layers, right? We talked about defense in depth. So in the same way, the layered approach to network security, it uses many different types of technologies like firewalls, IDIPS, and IDS, IPS, and more. Firewalls, I mean, you must be familiar. They're a core network security control, right? You're already familiar with it. It's important to know, like, not what they do, but also how they fit into a cloud's network security stack. So, like, firewalls are hardware or software based that monitor inbound and outbound traffic, right? You have customized rules which tell you allow or deny traffic. And traditional data centers, they tend to use hardware firewalls, but the heavy reliance of virtualization in cloud environments, I mean, they make software firewalls or mix of the two most suitable, right? And most modern firewall appliances are considered next generation firewalls. They have IDS, IPS, WAF, for another functionality all in one. So you have to, with when crafting your network security architecture, you have to think of each of these components as they're separate, right? Because you have to focus on each of these capabilities. So firewalls, they have two main roles in cloud networks. They have perimeter control and internal segmentation. So, and when you're in the cloud, you will be exposed to firewalls in two ways. You have something called virtual firewalls, which we talked about, and network access control lists, like you have in AWS security groups, right? So basically, that's how virtual firewalls work, and network ACLs, they allow you to define what traffic comes in, what traffic goes out. Okay. And next is IDS IPS. IDS IPS, it's like a hardware appliance or software that monitors your networks and systems and alerts if any suspicious activity is there, right? Same thing like IDS IPS, it's like one detects, one prevents, and usually you have a combination of the two. Most systems now, they have that functionality. Both of them are integrated. Previously, yeah, but just remember, guys, that when you install the IDS IPS, it takes a little bit of time to understand, right? Understand the environment, how it's working. If you just turn on the blocking thing from day one, you could actually cause a lot of problems by blocking valid traffic. So, and IDS IPS, they have that signatureless, signature based detection, just like antiviruses have. So, both firewalls and IDS IPS, they give you a very good level of control. There are two types of IDS IPS for the purpose of the examination. One is host IDS. It usually operates on a single host and it monitors only network traffic that comes into and out of that host, right? And they have able to look into more depth and monitor critical configurations on the files on the host. Like if somebody gives attacker, what do you call, somebody tries to compromise that machine, it's the host intrusion detection system that's going to detect it. And network intrusion, this is usually on the network path, and it's able to monitor network traffic across multiple hosts instead of just one. Usually they're installed after firewalls on a network tap, so they can monitor and look into, have visibility into all the raw network traffic which just go there. And network intrusion detection systems, they can identify suspicious trends across hosts that may be too hard to spot on individual machines. So both of them are good. You have to use both of them honestly to get a better idea of how your system is working. Honeypot. So if you watch those any movies have with hackers or attackers or anything, you'll be familiar with honeypots, right? It's like a decoy system that mimics a sensitive system in order to lure attackers away from the legitimate target. So usually they look like production systems, but they host dummy data instead of actual data. What happens is an attacker thinks this is an actual environment, and instead of doing a damage, they are looking at that, and by that time you get alerted, right? And you're able to access it. And last one is network security groups. So most cloud providers, they use the concept of a network security group. It's basically like a mini firewall, a mini ACL, and usually they operate at the server level, at the VM level. It's like I think it initially started with Microsoft, and it's there in Azure also. In AWS also. Basically, you're controlling the traffic which is going into and out of that environment, right? It's like an ACL, like a simple sheet. This traffic is allowed, this traffic is not allowed. Okay, the management plane. So when you're managing the physical or your logical infrastructure, and usually you have so many tasks like scheduling them and efficiently orchestrating all of those activities, they take place in the management plane. Okay, scheduling. So what can you do in the management and scheduling? Cloud infrastructure. It involves managing a variety of virtualized resources, and cloud providers. What they do is they employ task scheduling to make sure that customer requests related to these resources are properly being doing, right? Scheduling and resource allocation go hand in hand. So it's basically the process of taking customer resource requests and prioritizing those requests in such a way that they are like assigned and utilized most efficiently. So when multiple customers are requesting compute power, so the task scheduler is going to consider the nature of each request, right? Whether it's CPU, GPU, storage, the size of the request, how much compute power is needed, length of time, And based on all of these factors and metrics, it determines which customers to supply with the appropriate resources and for how long. So that's because it's something which cannot be done manually at all. And the next one is orchestration. It's another essential component of cloud management. It's the organization and integration of automated tasks between systems and services, right? If you use things like Puppet, Kubernetes, you'll be familiar with this, right? It allows you to create a consolidated workflow for multiple interconnected processes. So you can automate basically complex processes such as resource provisioning, allocation, scaling. And it's absolutely a necessity to enable cloud providers to give you like dynamically scaling services to customers, right? Without any human interaction. A lot of people sometimes they confuse orchestration with automation. Automation usually is like a single task, while orchestration is the coordination of multiple automated tasks into like one workflow. Okay. Last one is maintenance, and I think maintenance is pretty self-explanatory. It's like managing, the routine and emergency maintenance of the physical and the logical infrastructure. And maybe like in a normal on-prem environment it's easier, but you can imagine in a public cloud infrastructure you have thousands and thousands of customers. So you need to carefully consider what customer impact will happen when you're doing the maintenance mode, right? And they use things like orchestration, so it's completely transparent to the customer, like the traffic gets routed to another server and they're not aware while all the patching and everything is happening. Okay, so we've done this now. We're talking about implementing operational controls and standards. So we've talked about all of those underlying physical and logical infrastructure. Now we're going to talk about a lot of best practices and standards you can do, right? And like things like ISO 2000, 20,000 and ITIL and all those things which are there. Like I think ITIL is the most famous framework, right? It's like a framework that establishes a set of detailed IT service management practices, and you can take a look at that. Like this is a basic list of this. This is like the ITIL framework, right? And it uses like change management, continuity management. I'm not going to read all of them, but just take a look. You can go to Google and take a look at the ITIL framework. And all of these are basically, if you've ever worked in an IT environment, you'll be familiar with these activities, right? So I'm not going to go into too much detail on this. Okay, so this is interesting. This is a very fascinating topic, which I like quite a bit, which is supporting digital forensics. Digital forensics, sometimes they call it computer forensics. It's like a branch of cybersecurity. It deals with the recovery, preservation, and analysis of digital evidence, usually with cyber crimes, right? And like you have to interact with the law enforcement, technology, and it's like a fairly established field, right? It's a very interesting field also. As a CCSP, you have to recognize and understand how cloud computing, how it changes the way you do forensics, right? And this is very important, right? So the core principles of digital forensics are the same in the cloud as they are in traditional data centers. I mean, you must still collect evidence and conduct a thorough analysis of it, right? But the differences between the cloud environment and traditional data centers, some forensic issues are unique to cloud computing, like the things like data ownership and shared responsibility. Okay, you have to like think about that, because one of the biggest hurdles in cloud computing is the concept of the shared responsibility model, right? You don't in your own data center, you don't have any question about data ownership. It's your building, your servers, your data, but it can get a bit fuzzy when moving into cloud. And this is where a lot of times, sometimes you might have issues. If you're using infrastructure of the service, you have the highest level of ownership, right? You can simply access the data. But what if you're moving up for like platform as a service, and especially software as a service? You won't have that level of visibility, and you won't have that ability to request the logs also, okay, from the cloud provider. So some CSPs, and also they have policies that they don't share this type of information. So you have to understand like where you fall in, and as a CCSP you should be involved in reviewing all the cloud contracts and SLAs to determine whether the cloud provider can actually give you that evidence which you are looking for. Okay. And you have to enable like as a CCSP, you have to look at all those other controls which you have to implement, like encryption and everything. So remember, there are things like the shared responsibility model. You might not have access to the hypervisor logs. There's the concept of multi-tenancy. So if like you request access to the hypervisor logs, you might get access to logs for other customers also, right? And data location, meaning the data residency. A lot of times you might have problems because the data location is a separate one, and it might have PII, or it might not be allowed. So let's take an example, and you might have different laws and regulations that are governing that region, right? So court order is issued where the impacted data is located, like say Germany, and it might not be applicable to the same data stored in the United States. So you have, that's why sometimes a lot of cloud providers, they give you the ability to restrict that data, right? So as a CCSP, you have to understand what like sort of region you are in, what sort of regulations are impacting you, and all of these things when it comes to looking at evidences. So effective communication, it's like critical for any business. And as a service provider, especially a cloud service provider, you have to be able to like timely communicate with the other facts to customers, vendors, and partners to make sure for IT services, especially cloud providers, I mean, communication with regulators is a very important thing to consider, right? So let's take a look. So first one would be customers. As a cloud service provider, you have to communicate with customers. Those are your number one priority, right? You need to understand like what their needs and wants. And customers, they like to engage directly with the CSP personnel, especially during the early days when they're trying to migrate and they're trying to understand. So you have things like sales representatives, technical account managers, solutions architect. I work in Amazon Web Services, so we have multiple levels of account executives, security consultants, solutions architect, all of them to help you like migrate your workload to the cloud, right? Because we want to help them as much as that they can do. Apart from that, there would be like vendors, these sort of vendors which are there. They are a major part of the CSP ecosystem. And I don't know of like a single cloud service provider that doesn't rely on multiple vendors, right? Maybe hardware manufacturers, software vendors, outsourced maintenance professionals, many, many more, right? Many of these services are mission critical for CSP, and therefore effective communication with vendors is very, very important. You have to keep that in mind as a CCSP. Usually uh, they have like you have ongoing arrangements, ongoing agreements with them to make sure that you're following it. The next one is partners. Partners, I mean, if you've ever worked with a cloud provider, you have multiple partners. They provide their own solutions onto the cloud marketplace. Like AWS has so many partners, Azure have so many partners. They provide their solutions which are optimized for the cloud environment. And so they are working for the cloud and with the cloud to help customers with their solutions, right? And lastly, regulators. I mean, regulators, I don't think I need to tell you this, but regulators basically, just about every cloud provider and cloud customers have regulations to comply with, right? As a CCSP, it's your job to understand these regulations and help your organization craft ways to satisfy them. And the communication with regulators should happen early and often. So when you're first planning to build your infrastructure or making any changes, like a new region, you have to make sure the regulators are understood, are like fully on board. They've fully understood this. They have approved it, and regulatory bodies usually they are not that up to date on cutting edge technology. So it's the job of the cloud service provider to make sure that they are updated and they are aware and they understand the risks and how they have been mitigated. So this is how you communicate with all the other parties which are there. Okay, so now we've almost reached the end, which is like the security operations, and we've talked a lot about building and deploying security controls to manage the physical and logical components. It's as important to make sure that they have been implemented properly, and you have to monitor them. We talked about monitoring, but not from the security perspective. So now let's talk about something called the SOC. If you have ever worked in any department, a cybersecurity, you'll probably be aware of what the SOC is, right? A security operations center, it's like a centralized location where all the information security professionals they monitor and analyze your security posture. So it's responsible for the ongoing operational aspects. So they usually 24/7 and they are detecting, reporting, responding to security incidents. So usually if you think about SOC, you have those like a large room with lots of computers, monitors, right? And it's still there, but now you have things like virtual SOCs also happening. And especially when you have large cloud providers, right? They are completely geographically dispersed. So all, and as a CSP, you can imagine just how important a SOC will be. So that's the whole point of what the SOC is doing. And on a more tactical level, you have to monitor like the effectiveness of the security controls also, right? If you are putting things like encryption, put in things like integrity monitoring, anti-malware, patching, baselines, all of those things have to be monitored, right? You're doing things like vulnerability assessments, penetration testing, all those things are being monitored. Because if you don't do all of these things, you will not know whether your controls are working properly or not. Okay, so wow, we've almost, I think we've reached the end now. This wasn't as big a domain as the other ones. I think we have only one more domain left to go, guys. After that, we'll be finishing off the CCSP. Thank you very much, guys. Thank you for listening to me for talk for so long. It's almost 45 minutes now. Do like and subscribe to this video and to this channel if you find it useful, and I'll be seeing you in the next video.